Okay, so we've defined hazardous waste, we've talked about the different types of hazardous waste, we've discussed the laws that are involved, and now it's time to discuss how to manage hazardous waste properly. So what do we do with this stuff? We're talking more so here about the hazardous waste that's generated by industries, not so much by households. So how do we manage this properly on the industrial scale? All right, the first thing we can do is to avoid creating waste in the first place. We could produce less waste. And this is a nice option because not only does it help by avoiding creating waste, but it's also cheaper for the industries who are doing this. All right, it's very expensive to get rid of hazardous waste and dispose of it properly, so it's even cheaper to avoid creating it in the first place, so it saves money. If you are creating waste, what we can do is reuse and recycle. All right, and if you notice here, the 3 R's: reduce, reuse, and recycle. Alright, the next best thing would be to convert to less hazardous substances. So there's all kinds of different ways to treat waste. We can use physical treatments, alright, which might include incineration. There's chemical processing. And then there's something called bioremediation or phytoremediation. Alright, this is converting to less hazardous substances. Alright, and you should know a little bit about incineration already. If you burn waste, you get toxic gases out, and that could be a bad thing. It could lead to other types of pollution. Chemical processing, you are converting to less hazardous substances. However, you're using chemicals in the process, so there's a lot of byproducts there, and there's a lot of energy spent, and you could create different wastes in the process. But then you have bioremediation and phytoremediation, using microorganisms or using plants to convert to less hazardous substances. And this is a nice option because we're using natural processes and we're using biology in this case to convert to less hazardous substances. So that's a real nice option, and it's actually affordable and effective. All right, but those options don't talk about disposal, the grave for hazardous waste. So what are the different types of disposal? We used to do a lot of illegal dumping, which led to a lot of Superfund sites, a lot of contamination of groundwater supplies, a lot of human health effects. So illegal dumping is what we don't want to do at this point. So then what do we do with this stuff? Well, there's 2 different things we can do. We can either put it into retrievable storage or non-retrievable storage. Retrievable storage are things like surface impoundments, all right, secure landfills, deep well injection. And then non-retrievable storage, the things that we have out there are things like Yucca Mountain or the WIP plant, which is salt dome storage. Let's go through these options for disposal of hazardous waste and talk about the advantages and disadvantages of each. There used to be a lot of illegal dumping that occurred before RCRA and CERCLA and TSCA, and one of the case studies here is Woburn, Massachusetts, which a finger was really pointed at a tannery in Woburn, Massachusetts, who was dumping TCE, trichloroethylene, into an area behind their plant, which was directly linked to the groundwater, and it caused leukemia and some deaths in the town of Woburn, Massachusetts. And they made a movie about it called A Civil Action, which is pretty good, which is a pretty good legal thriller. But we used to do a lot of illegal dumping, which didn't look too much different than this. There's a couple of Superfund sites around our area where quarries were used, and it's very dangerous because these places have direct linkage to the groundwater table and drinking supplies. Another case study of dumping in the ground is the Snake River Aquifer in the 1960s in Idaho. All right, a lot of waste was generated in the United States nuclear program. In this case, there was 20,000 gallons of high-level radioactive waste that was dumped by the Department of Energy. So the waste was actually produced in a different state in New Mexico, and it was dumped in Idaho in the Snake River Aquifer, which is a drinking supply for 300,000 people. So again, we didn't know what to do with this stuff, and in some cases we still don't. So what do we do with it? And a secure landfill is one of our options. A secure landfill is just like a regular landfill, except it has a double liner. Alright, and hopefully if the first liner leaks, that second liner will provide enough stability so that nothing leaks into the groundwater. We still have our series of leachate pipes, we have our cap, we have our liners. So all the same problems occur with a landfill. All liners leak. Alright, we still have the same siting problems that we did. And we still have the same potential for groundwater contamination. Alright, so a secure landfill has its advantages and disadvantages. A second option for hazardous waste treatment or disposal is the plasma torch. The plasma torch can be thought of as a mini incinerator. Alright, so if you remember waste incinerators as an option for treating municipal waste, think of that on a hazardous waste scale on site. So a plasma torch is actually small and compact. It's mobile. You could take this thing right on site at some industry and you can use it to treat hazardous waste. It also produces no toxic ash. That's different from a regular incinerator, which does produce toxic fly ash. A plasma torch does not. Through the process of gasification, it literally vaporizes everything. All right. There are a couple of disadvantages, and the one big one is that it's super expensive. All right, and this is probably the one reason why it's not used a little bit more commonly than it is. It does produce a bit of greenhouse gases. All right, it can release particulates, and it does vaporize toxic materials. All right, so this is a relatively new technology that's being used more and more, but it is expensive, the plasma torch. Another option for the disposal of hazardous waste is called a surface impoundment. Now, a surface impoundment is used for liquid hazardous waste and is stored at the surface. All right, so I use my example of fracking fluid here, and a surface impoundment looks just like a pond. This is more so a temporary storage for liquid hazardous waste. Okay, now surface impoundments, thinking about storing liquid hazardous waste at the surface, the advantages are that it's very cheap, all right, and you can build these things very quickly. All right, the waste is obviously retrievable. It's right there on the surface for you, and you can store it indefinitely if you have a double liner. All right, but the disadvantages are hopefully obvious to you. Storing liquid hazardous waste on the surface, you could have flooding. All right, a liner leaks, or if there's no regulations involved and a company wants to save money, they might not put a liner down at all. All right, but liners leak. You can have air pollution. All right, if you're storing liquid hazardous waste at the surface, the water will evaporate, hopefully leaving the contaminant behind as a solid layer, and then you have to dispose of that layer as hazardous waste, maybe in a secure landfill. But some of those toxins or contaminants may evaporate with the water and get into the air and be transported. All right, so you have a bit of air pollution. You can have freeze-thaw of the liners. All right, and that might crack them or tear, and then you have groundwater contamination. So there's a lot of disadvantages to surface impoundments, but it's a cheap and quick way to temporarily store liquid hazardous waste at the surface until it can be moved to a more secure location or permanent disposal site. All right, here's a couple of trucks filling up a surface impoundment that has a liner installed, and you can see it's by the millions of gallons. Each surface impoundment can hold about 15 million gallons of fluid. All right, and here's another one that is located nearby a farm. They're supposed to be about 300 feet from a residence, all right, which is fairly close. In this case, it's surrounding some farmland. All right, and here's a picture of the Colorado floods of 2013. There you see the well in the middle, and you can see the amount of flooding that occurred, and in this case, the surface impoundments flooded into a nearby river, and all the contaminant is gone into the local river and downstream. All right, another option for waste disposal are injection wells. Now, it is what it sounds like. So what we can do is we can take our hazardous waste and inject it down a well into a deep geologic deposit. All right, so on the right here, you see a municipal waste treatment plant is injecting wastewater down into a layer of rock or sand that's between two impermeable layers of rock. So this layer is impermeable, and so is this one. So what they're going to do is inject the waste material in here and just have it deep underground. All right, now that's the municipal wastewater treatment plant. The chemical plant is going to want to go very, very deep, well below any drinking water or shallow aquifers where drinking water is coming out of. So if we go very, very deep, hopefully we can find a layer of permeable rock between two layers of impermeable rock. So that contaminant is basically stored underground. All right, there's some advantages and disadvantages of this. Okay, believe it or not, it's cheap and easy. All right, it's a safe option if the location is chosen carefully. Okay, and also, believe it or not, you can retrieve the waste if you have to. So if you have a contaminant that's moving or it's threatening groundwater in some way, you can actually pump it back out. The disadvantages are great when it comes to injection wells. You can have leaks at the surface if you're not careful. All right, the well casing, each well has to be cased with steel or concrete or both. All right, that well casing could be compromised, especially in like an earthquake or something like that, and then you have groundwater contamination. All right, earthquakes are a problem. If you pump waste down in between two impermeable rock layers and an earthquake makes them permeable, now your material can migrate or move. All right, and it also does nothing to encourage the reduction of waste. It actually encourages, because it is so cheap and easy, it encourages waste production. We could just inject it down a waste or an injection well. All right, there's various classes of injection wells, and a class 1 well is what I just spoke of, where you're going to inject hazardous materials deep below drinking water supplies and in between two impermeable boundaries. But the class 2 wells are where we're going to inject waste into an old oil deposit. All right, so right down here, once you pump out the oil, you now have void space where there was a liquid within the rock itself. So we're going to use that void space and pump down hazardous waste. So that's a class 2 well using an old oil deposit. A class 3 well is where we're going to use an old salt dome, all right, where we mined salt, and we're talking about common table salt. So we're going to inject fluids into an old salt deposit or a mineral deposit. If you notice here, here's the salt deposit. They look like these domes, and inside of it we have a void space. So we're going to inject hazardous waste material into that salt dome where there's a void space. And what's great about salt is that it seals its own cracks. So if we put the waste down there, we can be very confident that it's not going to move. It's not going to jeopardize any water supplies or anything, because if there's an earthquake and a crack forms, the salt naturally seals its own cracks. A class 4 well is actually banned by the EPA. Now we're talking about an industry or a manufacturing plant that's injecting material into the drinking water supply. All right, very shallow deposits. So those have been banned by the EPA. Just kind of know these different options and that there's different classes and the ways we use injection wells in different ways. All right, and then that brings us to managing nuclear waste. Very interesting topic, because there is no permanent facility to store nuclear waste. So because there's no facility, nobody knows what to do with this stuff. All right, we're talking about high-level radioactive waste, spent fuel rods, things like that. Because there's no permanent site, this stuff is all stored on site at each nuclear facility around the country. So if you look at Limerick here, somewhere on site is all the spent fuel rods that have ever been used. All right, and that's an issue. Okay, one of the things we do is we store it in what's called tombs, and you can use these canisters, these cylindrical canisters, to store the nuclear waste, and then we'll put it into these concrete tombs. Here's another example of the tomb where they're retrievable. All right, it's temporary until we figure out what to do with this stuff, but the tomb is an option. This is another picture of the basement of a facility or somewhere on site at a nuclear facility where they're storing those canisters within a pool of water. They store it within the water because that keeps the temperature okay. These are spent fuel rods that are not used anymore because the reaction has slowed, and on-site temporary storage until we figure out what to do with this stuff. Okay, there was a facility developed in Nevada called Yucca Mountain. It was chosen because it's relatively soft rock, so it was easy to drill into, and it's in a very remote location in our country. It has a deep groundwater table, and Yucca Mountain was designed, constructed, and built, but it is not currently being used because of political reasons. All right, the people of Nevada did not want to be a waste state. They did not want to be known as the country's nuclear waste dump, and they petitioned against it and actually fought it enough that it was never brought online. So right now we have Yucca Mountain, which is a tunnel facility, and here's the entrance to Yucca Mountain, and what you're looking at is like a conveyor belt where these little train cars will take the waste into the tunnel and take it down into the storage facility. So here's the drill bit. You can see it's a big one to drill the tunnels. And here's the site in a nutshell. A train would come in bringing the nuclear waste. It would be loaded onto a conveyor belt and taken down into these tunnels for permanent storage for thousands and thousands and thousands of years. All right, little train cars will take it down into these tunnels. It sits there built, but not used. All right, here's what the little cars might look like to take the nuclear waste down. There's the cylindrical canisters. All right, funding for development of Yucca Mountain was terminated in 2010, and the license was withdrawn in the next year. This leaves the United States with no long-term storage site for its high-level radioactive waste. It is now still stored on site at all the various nuclear facilities around the country. Lots of nuclear sites around the country, and these are power plants, commercial reactors, there's research reactors, there's all kinds of places around the country that are producing high-level nuclear waste, and that waste is still stored on site at these various facilities. All right, so what do we do with America's nuclear waste? Again, it's just stored, but there is a plant that's in operation, and it's called WIPP, the Waste Isolation Pilot Plant. In Carlsbad, New Mexico, it's a permanent salt mine storage facility, which is planned to be used for the next 10,000 years. It's somewhat of not an injection well. They actually drive the materials down into the salt mine for permanent storage. All right, but I like this picture because it shows a salt deposit, and you can kind of get a sense for this. But there's a video that I'm going to want you to watch, and it's called What to Do with America's Nuclear Waste. It's on my website under this unit's videos. So you're going to want to know about the WIPP storage site, which stores not high-level nuclear waste, but more so low-level nuclear waste and true waste, that transuranic waste developed during America's nuclear program. So we like this because salt seals its own cracks, it is isolated, and there's very little chance for groundwater contamination in this scenario. All right, there are problems with it. Earthquakes can be a problem. If there's any leakage of any radioactive material, the workers at the plant could be exposed. So there are problems, but again, there's not much to do with this stuff, and this is an option. All right, and I'll just finish here with the Finnish model. This is a deep disposal radioactive waste site developed in Finland. So they're developing very similar techniques to Yucca Mountain, where they drill and develop an underground storage facility in their country. So other countries have the same problems, and the world is trying to deal with the fact that we have nuclear waste that will be radioactive for hundreds of thousands of years. So this lecture was all about the disposal methods, and hopefully you get a sense for some of the advantages and disadvantages of our options, but hopefully you also get a sense that disposing and treating and storing hazardous waste is an issue that we should be aware of, and the best thing to do would be to reduce, reuse, and recycle, but when those options aren't feasible, we just have to store this stuff and hope that it's properly managed. Alright? Don't worry, be happy.